Hello everyone. This is the second lesson on the topic Surds. In the first lesson, we discussed about what are Surds and some multiplication properties related to the Surds. In today's lesson, we will be focusing main on the addition and subtraction in Surds, and one multiplication property was left, so we will be discussing that as well, and it will be followed by expanding brackets which involve surds. These kind of expressions will be there, like expansion of brackets, but a, b and c here, they will be, some of them will be in the form of surds. So let's begin our today's lesson. So here we have given this, it's written simplifying products. So simplifying products, basically we are multiplying, and then whatever the results will come, we will try to simplify, make it as simple as possible. So we have here three rules. Out of these three rules, we already discussed the rule second and rule third, but the first rule is was left over, so we will be discussing this. What does it mean if you have the surds and you have the same surds? For example, square root of 2 multiply by square root of 2. So how can you write it? Square root of 2 and whole square. How we can write it this way? Because we know the squared numbers, we know that concept. If you have, let's say, 3 multiply by a 3, that is written as 3 squared, and then we can write it as 9. So same rule is followed in the surds also. If we take the first surd is square root of 2 and second surd is also square root of 2, so that means this is square root 2 and square of it. And one thing you need to remember always, that square and square root, they are inverse of each other, so they cancel each other's effect. When you will be learning about the indices, law of indices, you will learn it in great detail for the fractional indices. Okay, so square root 2, so this sign, square root sign, and the power square, they are inverse of each other, so they cancel each other's effect. So only thing which will be left over, that will be just 2. So that will be our answer. Let's try one more example. For example, you have 14, let's say, square root of 14 times by square root of 14. So I can write it like 14 and then square of it. In the last session, I was telling you this one. This basically we applied. You can apply the same here also, but normally we apply this one when you have A and B different. If they both are same, then also we can do in that way. But if you do that way, it will be a little longer. I will show you the difference. So first I am doing it in this way. When you have both A and A square root, so we can directly write it this way, and then square and square root effect will be cancelled because they are inverse of each other. So our final answer will be just 14. Now, if I do the same question using this second method, you can do it. Okay. So it will be square root 14 times by another square root of 14. So we will be writing it under one square root sign, square root of 14 times square root, like 14 and times 14 and one square root sign. And then you will multiply it, so that will be 196, and then you will try to simplify it, which is 14. Now see, you can do this method, there is no harm, only it will be little bit time consuming. First of all, you should know that 196 is a square number, you can find its square root very quickly. You need to know those things. Okay, so this method is also fine and this is also fine, but this is a little quicker method. Now let's go to the some exercise questions based on the same concept. We have already done this part, square root and square. Now next part comes where you have square root 2. Here you have square root 2 and then you have the power of 3. So what does it mean? It means it is square root of 2 multiply by square root of 2 multiply by square root of 2. This is very important. If it is written 3 here, that means you need to times 3 times, because it means you are finding the cube. So for example, you have 2 cubed. What does it mean? It is 2 multiply by 2 multiply by 2. So you are multiplying 2 3 times. and that is equivalent to 8. So this is what you need to do here as well. Now if you see this part, square root 2 multiply by square root 2. So I can write it square root 2 the whole square times by square root 2. This square root 2 I will keep as it is because I don't have any other square root 2 to pair it with. Now square and square root here, it will cancel each other. So I got 2 and multiply by square root 2. And we know that this multiplication sign is not required because one is a non-surd part and one is a surd part and they are in multiplication. So I can just write 2 square root of 2. Clear? Always remember, you can cancel this sign square root with square. If there is a cube here and here is a square root sign, you cannot cancel. It should be cube root, then only you can cancel. Okay, whatever is number is written over here, same number should be written over here, only then you can cancel. Second important thing, it is not 3 root a. This is, I am talking about cube root of a. If it is cube root of a and then this power, then you can cancel this. Okay, now let's do the next question. 4 over square root 2 the whole square. 4 over square root 2 the whole square. So this is like a over b the whole square. What you can do here, you can take the square of the numerator separately and denominator separately. Now 4 square is 16 and square root here will be cancelled. So you got 2 and then 16 over 2 which is equal to 8. So that will be our final answer. Then let's go to the next one. Okay, here we have the normal multiplication questions, but the square number is not just a surd, it has another number multiplied with it. So it is multiple of surds. So you have 3 root 2 square. What does it mean? Its meaning is 3 squared and root 2 squared. Why I am writing it like this way? Because we know that if you have AB the whole square, this is basically A square times by B square. So that way I have written. So this will be 3 square is 9 and root and square sign will be cancelled each other. So 9 multiplied by 2 which is 18. Same question, you can do it in one more way. You have 3 root 2 square. That means 3 root 2 times by 3 root 2. So here these all numbers are in multiplication. When I say 3 root 2, that means it is 3 multiplied by root 2. Then another 3 multiplied by root 2. What we do in surds, we multiply the non-surd parts together. So 3 times 3 which is 9 and root 2 times root 2. That is root 2 squared. So square and square root will cancel. You will get 9 times 2 which is 18. Please make sure when you go to the surd part 2 lesson, you follow first the first surd 1 part. Then only you will be able to do the second part easily. Otherwise, you will find it's a little bit tricky. Next. Okay, next we have addition and subtraction of radicals. Now, radical word, if you remember in the first lesson, we discussed it. Radicals means the same as surds. Like you have square root a, so this is a surd, this is a radical. Now, how do we add or subtract the radicals? If you remember the concept of algebra, how to add and how to subtract in algebra, only like terms we can add. For example, if you have x plus 4x, yes, you can add them. It is 1x basically if I don't write anything in front of x. So it will be 5x. So in the algebra, the terms should be like terms if you want to add them or if you want to subtract them. Same is the case of surds or radicals. Just here the variable part should be same as in algebra. And when you add or subtract the surds, the radical part like square root part or cube root, whatever it is, that part must be same. So now in the first question, we have 3 root 2 minus 4 root 2. So can I add, subtract these two surds? Yes. Why? Because the surd part is same. Only you need to focus on the surd part, that must be same. Other part which is non-surd part, like it is a multiple of 3, so that 3 and 4 they are different, it does not matter. So it is something like 3x minus 4x, you can consider it like this way. And then we can subtract them because these are like terms. So these are the surds, we can subtract. Now 3 take away 4, it is negative 1 square root of 2, and negative 1 we don't write, we just write the negative sign and square root of 2. That is our answer. Then we have the next question here. Square root of 7 minus 2 times 1 minus square root of 7. Now, if you know how to expand the brackets in algebra, so this question can be done very easily. So what we need to do, this is square root of 7. As per the BODMAS rule or PEDMAS rule, first we need to expand this bracket. Whenever you have a bracket in your question, you have to simplify that. So this is negative 2 times 1, which is going to be negative 2. Then you have negative 2 times by negative root 7. So negative number times by negative, your result will be positive. So it will be plus, and you are multiplying 2 by root 7, which is just 2 root 7. Now here, can we add all of these terms, root 7, negative 2 and 2 root 7? No. There are two like terms as in algebra. What are those two like terms? Square root 7 and 2 square root 7. So square root 7 means it is 1 square root 7. So 2 plus 1, 3. So this is 3 square root of 7. Take away 2. So this is the final answer. Because I cannot do any calculations with negative 2 because these two are not like terms. So we have to leave it like this way. Then let's go to the next part. So we have here so many questions which are based on addition and subtraction. I'm going to pick, let's say, the last two questions. Then in the next slide, the questions that you can solve on your own. So we have here, I am taking this question I. It is 3 root 3 minus square root of 2. And then we have minus 1 minus square root of 2. So when we simplify, we have to first of all solve the parenthesis part. So this is 3 root 3 minus square root of 2. Open the bracket. If nothing is here, it is minus 1. So see, there is a minus sign here. What this minus sign says, if you have a minus sign before the parenthesis and you open the brackets, the signs inside will be changed. So this is a plus 1 here. This will become minus 1. And this is a minus root 2 here. This will become plus square root of 2. So now what I got, 3 root 3. Then we have negative root 2 and positive root 2. First of all, these are the terms we can add or subtract because they are like terms, like as in algebra. So one is negative root 2, one is positive root 2. So that will be 0. And then we are left with minus 1. Now 3 root 3 and 1. These are not the terms that we can solve. So we can keep it as it is. This is my final answer. Then let's go to the K part. In K part, we have here two brackets. So we will be simplifying both the brackets. So we have 3 times root 3. I'm simplifying the first bracket. Then we have 3 times 3 times root 2. So minus 3 root 2. In the second bracket, if you see, we have negative sign outside. So all the signs inside will be changed. So negative root 2 plus positive root 3. This is a very important point. If you have a bracket and you have here, let's say a minus b, and there is a negative sign, when you open the bracket, this is positive here. So this will become negative, and this is negative here. This will become positive. Okay. When we will do algebra, I will explain in detail why it is so. Now we have to find out the like terms here. So 3 root 3 and root 3. These are the like terms because the surd parts are same and we have to add them. So it will be 4 root 3 because by default if nothing is written, so it is just 1. Then we have negative 3 root 2 and negative root 2. So negative 3 root 2 and negative root 2, it will be minus 4 root 2. And you can give your answer like this. Now, based on the same, you can try all of these questions. It will be easy. Next here, these are all the questions which are based on exactly the same thing which I have solved in the beginning of this session. So I will pick a few of these questions with the higher powers. Let's say we have this one, square root 5 to the power of 4. So basically its meaning is square root 5 times square root 5 times square root 5 and times square root 5. Now, because it is a square root, so I will try to form the power of 2. So that is why I am taking these two. Okay. Why I am taking these two? Because I know this sign is inverse of 2. So I am trying to take that power. So first I expanded it like square root 5 times square root 5 times square root 5 times square root 5. And then I write the first two as this one and the same last ones. Square root cancel, square root cancel. So what I got here is 5 times 5, which is 25. This is the answer. You can do it in multiple ways, like you found it square root 5 times and so on. You can write one square root sign and multiply all of the 5's together. Then you can write it, this all multiplication, it will be 625 and square root of 625 is 25. So this method is also fine. Whichever method comes to your mind, you can apply that method. Then the next is same kind of questions, but I will be choosing, let's say, the last few questions from here. So for example, question P, minus 2 root 3 minus 2 root 3 times by minus 5 root 3. So here it is like A times B kind of stuff. What does it mean in actual? It is minus 2 times root 3. You can take one of them as negative. Okay. Same way, you have minus 5 times root 3. So here, minus 2 root 3. Now we have surd parts and non-surd parts also. This is a non-surd part. This is a non-surd part. We can times them together. So it will be 10 times by root 3 times root 3, which is root 3 squared. So 10 multiply by square and square root cancel 3. So this is 30. This is one of the way that I wrote all of these, both the surd values as like negative 2 times this and this sign. Then we know multiplication can be done in any order. Don't do it like, see, some of the students, they might think like this also. Let me explain that as well. That minus 2 root 3, first you will multiply it by 5 and then minus 2 root 3, you will multiply it with root 3. But that is wrong. Why? Because here is no sign of plus or minus. If it is minus plus or something like that, then you have to do this. But here it is a multiplication. So then you will not do anything like that. Then second method, what you can do here is, you had negative 2 root 3 times by negative 5 root 3. So these are the two terms. This is one term and this is another term. They both are negative. So when you times the two negative terms, if no sign in between, that means it's a multiplication. So when you multiply two negative terms, that will become positive. Then 2 times 5 is 10. Root 3 times root 3 times root 3 is root 3 square. So 10 times 3, because square and square root cancelled, and we got 30. Clear? Then let's try one more question. For example, this one, square root of 2 times by negative 3 root 2. So again, here is a multiplication. So you will not do like this, root 2 times negative 3 and then root 2 times root 2. That will be wrong because there is no plus minus here here. There is no plus minus. So you can't expand in that way. So we have root 2. We have to multiply it by negative 3 root 2. So basically it is minus 3 because there is no surd part, it is just 1. So negative 3 times 1 is negative 3. And root 2 times root 2, that is root 2 squared. Square and square root cancel. So negative 3 times 2, which is negative 6. Clear? Then let's go to the next one. Yeah. So now I have explained some of the questions in based on the multiplication, various kinds of multiplication expressions were there. So I tried to cover almost every type of expression from there. Now we have some division based questions, though we have done, but let me explain that as well. So here, let's try this question number I. We have 3 square root of 6 divide by square root of 2. We can divide the two surds even if they are same kind of surds or not. Like it's not mandatory that it should be root 6 over root 6. That is only for addition and subtraction, like in algebra. So here what I can do, 3 square root 6 over square root 2 I can write together under one square root sign, because we know that if you have roots b over root a or root a over root b, you can write it under one sign. So this will be 3, and here if you simplify, this is 3 root 3. That will be your answer. Then we have the next one. Let's say we take the last one, 3 square root of 98 divide by 2 root 2. Now here the non-surd part is 3 by 2. We cannot simplify, so I will write it as it is. If let's say it is something 16 by 4, so I can simplify and I can make it 4 as well. But here it is 3 by 2. So non-surd parts will be separately, we will solve separately. Then we have square root of 98 over 2. In one surd sign I have written, they both are square root, then only I can write. If it is, let's say, square root of 98 and here it is a cube root of 98, I cannot write like this then. This way then I cannot write. They both should be square root, or they both should be cube roots, and so on. So I am trying to include those points where the students can do mistakes. So that's why it is important to like highlight those points. So this is 3 by 2. Now 98 over 2 is basically square root 40. This is 49. 98 over 2 is 49. And 49 square root is what? 7. So this is 3 times 7 over 2. Now some students, what they are going to do here, they will multiply 3 by 7 and they will multiply 2 also by 7, which is wrong. Because this 7 is only in the numerator, its denominator is 1. If a whole number is written like 7, 8, 14, you can write it in fraction, but just by taking the denominator as 1. Very important point. So far we reached up to this point, 3 by 2 into 7 by 1. So 3 times 7 we will multiply, which is 21, and 2 multiply by 1, which is just 2. Now, when you gave your final answer, what I found here, that this is an improper fraction or a top heavy fraction. You have to give your answer as a mixed number in this case, or decimal if it is a terminating decimal. So I can write it like 10 and a half. You can write your answer like this. Do not leave it 21 over 2, even if it is mentioned or not. Better to give your answer as a mixed number. Only while the operations you are performing, you can use the improper form, that is okay. But final answer you have to give as a mixed number. Then let's do the next one here. So now we have the expansion. Now why I have mentioned these rules? These rules are basically the rules of expansion in algebra. Exactly same rules we follow with the surds. Okay. So we have like a times b plus c. So if I give you like 2 times 3 plus x. So what we do? 2 times 3 plus 2 times x. Then we will write 2 times 3 is 6 plus 2 times x, 2x. So this is my answer, 2x plus 6. You can write your answer as 6 plus 2x, but in maths, what we do, this is just a convention, we always write the higher variable terms, like the powers of the variable. We have to see if it is the highest, that term should be written at the in the beginning, then followed by the smaller powers. So now we will be following the same rules. Okay, let's try with some examples. So you have 2 times, let's take this one, 2 times 2 plus root 3. So we will expand 2 times 2, which is 4, plus 2 times root 3, which is 2 root 3. Now you have to see, can you further simplify it? No. So we have to stop here. If you look at the second question, we have root 2 and then inside we have 5 minus 2 root 2. Same thing you have to do. Root 2 times 5. Can we write it root 2 5? No. We have to write the non-surd part first, followed by the surd part. So it is 5 root 2 minus root 2 multiplied by 2 root 2. Now root 2 multiply by 2 root 2. So here non-surd part is 1. So 2 times 1 is 2. And then we have root 2 square because there are 2 root 2's in multiplication. That will be cancelled out. So we got 2 times 2, which is 4. So this is the final answer because we cannot further simplify as one is having a surd and the second part is not having any surd. Now let's go to the next one. See, this expansion can be given up to any level like single bracket, two brackets, and so on. These two questions I want you to try. Make sure you follow the signs properly. So here we have lots of questions. You can practice all of them. I'm going to pick one of these questions. Let's say this one. Here we have negative root 2 cubed times by 4 minus 2 root 2. So first of all, what I can do, I will try to simplify this negative 2 cubed. Negative 2 cubed means what? Negative 2 cubed. This means it is negative root 2 times negative root 2 times negative root 2. Now negative root 2 times negative, this negative into negative will become positive. So, and then this positive times negative, it will become negative. So the final answer will be negative for this multiplication. And also we know that if you take a cube of negative number, it is always negative answer. Okay. Then we have, it is square root 2 times square root 2 times square root 2. So far, negative sign is because of the result of all these negative signs. I have resolved the sign. Now we have negative and root 2 times root 2. If I take these two, so this is negative 2 root 2 square times by root 2. This is minus root and square will cancel, so it is 2 and then this root 2. So basically, when you write negative 2 cubed or you write negative 2 root 2, they have the same meaning. Now I will start the expansion in actual. So I will write negative 2 root 2 times by 4 minus 2 root 2. Now here it will be these two numbers multiplied. So 4 and 2 will be multiplied because they are non-surd parts. So negative 8 root 2. Then negative into negative will become positive. And this is 2 root 2. This is also 2 root 2. So this is 2 root 2 square. Now the question is, can I simplify 2 root 2 square? Yes, we can. It is 2 root 2 times by 2 root 2. So the non-surd part is 2 by 2, which is 4. And then we have square root 2 times square root 2, which is square root 2 squared. They will be cancelled. So you got 4 times 2 and that is equal to 8. So I will give my final answer as negative 8 root 2 plus 8. This is the final answer. Make sure you use all of these parts, these working you have to show in your exam how you are getting these answers. Don't just write 8 directly. Okay. So now some rest of the questions are easy. You can do it very easily. Now we have the last part, which is expand and simplify. That means first, because there are two brackets here. So if you all know the algebra, you know how to expand the two brackets as well. You can apply first in, last out, those methods, or you can expand in any way, whichever way is convenient for you. So I'm going to solve the last question. Let's say I, not J, I. So we have 3 root 2, 3 root 2 plus 1 times 3 root 2 plus 3. So first in, last out. So first terms from both the brackets. So it will be 3 root 2 times 3 root 2. Then inner term. So this is inside term and this is inside term. So 1 times 3 root 2. Then the last terms, that is 1 into 3. And then the outer terms, this is outer term and this is outer term. This is a FOIL method. You can say first in last out, or you can remember it like FOIL method. First, then outer terms, inner terms, and then the last terms. Either way. Then it will be 3 root 2 times 3. Now 3 root 2 times 3 root 2. So 3 multiplied by 3, the non-surd part, it will be 9. Root 2 multiplied by root 2, which is root 2 square. And square root will cancel. So it is 9 multiplied by 2. Then plus 1 times 3 root 2, which is 3 root 2, plus 3, and plus 3 root 2 times 3, which is 9 root 2. So this is, so far what I did is called just expansion of the brackets. Now there is one more step I need to do. So I got here 9 times 2 is 18 plus 3 root 2 plus 9 root 2. So I can find some like terms. So that is 12 root 2 and plus 3. Again 18 and 3 are the like terms. So you can do 21 plus 12 root 2. You can do it in the same step, like you can solve the surd parts and non-surd parts also. Sorry, this is not the part. So you can, when you were simplifying 3 root 2 plus 9 root 2, at the same time also you can write 18 plus 3, 21. It is up to you. But just my advice is to go step by step. Do not miss even a single step like, okay, let's do it directly, because then there will be chances of errors. Okay. And always recheck your work. So this was all for our today's lesson. In this lesson now, as a summary, what did we cover? We covered how to add and how to subtract in using surds, how to expand the brackets when it involving surds, and we use this rule a lot, that is square root of a times square root of a, that is square root of a whole square. And we know that square and square root, they are inverse of each other. That means it will give me just an a. In our next lesson of surds, that will be our last lesson on the surds, we will be discussing about the rationalization, a very important